Good morning. Today we're going to do chapter 4, section 4, which is the part 2 of factoring. Part 1 was what we did before Thanksgiving. We're going to start with part 2. Now, this has to do with the greatest common factor. So, what is the greatest common factor? It's a common factor of the terms that can be factored out of the expression. So, common factor of the coefficient and exponent. So, for example, you can have something like 3x squared plus 6 plus 6x, and you can actually factor out a 3x. So you would end up taking out a 3x, and you would end up with a 3x on the outside, an x in the inside, and then plus 2. Now, why would this be the greatest common factor for these numbers? Now, I can take out the x, one singular x, because the 3x squared and the 6x both have an x. So I can take the common, which is just one x. That's why it's x on the outside. And I can take out a 3 as well, because 3 times 1 is 3, and 3 times 2 is 6. So 3 is the factor of both of these terms. So you can take out the biggest factor from both terms. It could be 3, 4, 5, 6, a lot of terms, but you will always be taking out the greatest common. It can be multiple letters, variables, or it can be different numbers. So in this case, it's a 3. It can be sometimes a 2, a 4, an 8. And you will know if you're done because you cannot take anything else out from the parentheses. Now, you can check your work by actually distributing that 3x back. So if you do that, you're going to get 3x squared plus 6x. So because after you distribute, you get the same thing back, you know you took out the greatest common factor correctly. Now, your answer would be the 3x and the x plus 2. This would be your actual final answer. But I'm just saying, if you want to check it, you can always just distribute the greatest common factor back into the parentheses, and you can check your work. Now, notice for example 1, you have a 6x squared and a 9x. Take the numbers by themselves and then figure out the x's. You don't have to take out the greatest common factor in one singular step. So if you take out the numbers first, what are two values that are factors of 6 and 9? We have value of 3. So we can take out a 3, and we end up with a 3 and then a parentheses, 2x squared plus 3x. Now, since the numbers are fully factored, because 2 and 3, the only common factor is 1, we can stop with the numbers. Now, let's look at the variables, the x. We have multiple x's inside, so we can take out one x, and we're going to get 3x, and then parentheses, 2x plus 3. So this will become 3x, parentheses, 2x plus 3. And since we don't have any more variables inside of the parentheses, you're done with the variables. And we had finished with the actual numbers first, because 2 and 3, the only common factor is 1. So therefore, your solution is 3x, parentheses, 2x plus 3. But as I mentioned, notice that this one only has numbers that are multiples of each other. What's a multiple of 7? 7, because it's a prime number. And ones are multiples of 21 that deal with the 7. So 7 and 3. So we can take out a 7. And we're going to end up with 7 and the parentheses x squared minus 3. Now, since there's nothing else I can do to this, because inside of the parentheses, only one term has a variable, and only one term is a variable or a multiple of 3, this will be your final answer. So the 7 parentheses x squared minus 3 would be your final answer. All right, so for example 3, now we have 3 terms. If we look at them, all of them have a factor of 3, a factor of 9, right? So you can do it by listing the factors out. So your factors of 9 are 1 and 9, 3 and 3. And your factors of 18 and 1 and 18, 2 and 9, 6 and 3. Now, you can also, after you do this, notice what is the biggest number that they share. In this case, they both share a 9. So I will mark those. Because that is the greatest factor that they share, you can take that number out for all of these. Now, I didn't do a third variable because we have 2 9s in the number. So, if I take out a 9, this will become a 1. So, it's going to be 9, parentheses, x squared. Now, I take out a 9 for the second one. It's going to be x by itself. And then when I take out a 9 from the 18, it's going to be a 2. And this will be your final answer. Because the x squared is x and the negative 2, you cannot take anything else out of it. Now, you can factor this out like we did before the break, and we will do it so you guys can practice. But I want you to note or notice that since we took out a 9, wherever there was a 9, right? It became a 1, which is its complementary factor. When we took out a 9 from the 18, the complementary factor was a 2. So please keep that in mind. This is always going to be the case. Now, how can I factor this equation? Remember, they have to multiply to this number. So they have to multiply to negative 2. So your factors are either going to be plus or minus 1 and plus or minus 2. Obviously, how are we going to know which one is which? Now, how do I know which is which? We want to make sure they add up to this factor, which is positive 1. Yeah. So you would write 9 and then a parentheses separating the x's. Now, since we want to make sure they multiply to negative 2, the only two factors we can use are 2 and 1. So I'm just going to go ahead and plug them in. But how do I know which is a positive and which is a negative? Since we want it to add up to positive 1, we're going to make sure that the biggest number is positive. So it's going to be an x plus 2. But we want to multiply to negative 1. So we want to make sure we put the negative at the 1. When you add positive 2 and negative 1, you get positive 1, which is that middle term. When you multiply 2 times negative 1, you get that negative 2. So your fully factored equation is this one. The 9 and then parentheses, x plus 2, x minus 1. This would be what you would consider your final answer. So here we actually notice we combined multiple steps. We combined the greatest common factor for factoring, and then we factored out the same way we did right before break. All right, so for this one we have a 2x squared minus 6x plus 8. The greatest common factor for all of these numbers is a 2. So you can take out the 2 to get 2x squared minus 3x plus 4. Now we're going to factor. We're going to look at the factors that multiply to 4. So we're going to have the factors of 1 and 4 and 2 and 2. Now, since we wanted to add up to negative 3, the factors that you'll most likely want to use are the 1 and the 4 because you can subtract them from each other to get a negative 3. So you're going to do 2, the parentheses, and parentheses. You're going to plug in the 1 and the 4. Now, how do I choose which ones to use? We wanted to add to negative 3 and multiply to positive 1. We can make it add to negative 3 by putting a negative 4 and a positive 1. But if we were to multiply those together, they don't give us positive 4. Just because this doesn't give us positive 4, we can scratch it off, and your solution is actually going to be the very first part, which is just 2x squared minus 3x plus 4. If I take out a 5, I'm going to end up with 5 and then parentheses 2x squared plus x, right? So I can take out an x and it's going to end up being 5x and then 2x plus 1. So your final answer would be the 5x and then the 2x plus 1 as your final answer. I'm going to write the factors of 4, the 16, and the 12 to see which one is the largest factor. Factors of 4 and 1 and 4. The factors of 16 and 1 and 16. 2 and 6 and 4 and 4. And for 12 and 1 and 12, 2 and 6, 3 and 4. So the factors, the biggest factor that they all share is 4, right? So we have the 4, and the 4. So let's take out the greatest common factor for all of the numbers. So it's going to be 4 on the outside. And then inside the parentheses is going to be x squared plus 4x plus 3. Now we have to figure out if that is factorable or not. We're going to look at the factors of 3 that add up to positive 4. So the factors of 3 are just 1 and 3. I'm just going to write them here just to write them down. And you can add them to 4 by adding them together. So I'm going to go ahead and write 4 parentheses x1 and then x3. Now I have to figure out whether they're going to be positive or negative numbers. We want them to add to positive 4. So I'm going to go ahead and do a plus on both of these. Because 3 plus 1, both being positive, will give us that positive 4. And positive 3 times positive 1 gives us positive 3. So because it does work with the rules, they multiply to positive 3 and they add up to positive 4, this will be your final answer. That's it for today's notes. Please turn them in. They are due for these notes.